Hello again, this is Section 8. This is Day 3 of our e-learning. We're going to do Section 8, which is geometric series. Unlike our arithmetic series, we're going to have to use this when we're dealing with a sequence that you want to add together with a common ratio, not a common difference. In order to find that ratio, we learned that we can divide any term by its previous term, and that will tell us what the ratio is. The ratio could be positive, it could be negative, it could be a fraction, it could be bigger than 1, it could be less than 1, but anything. There's no real restrictions on what those ratios can be. We have 2 exercises to work on in this section, but before we can do that, we have to talk about what this formula is and how it works a little bit. So again, we use this formula only for a geometric series. Because geometric series can be infinitely long, we're only going to add together a part of that series, so we're going to call this a partial sum formula. The formula uses only 3 variables in it, and the 4th variable would represent the capital S, which would represent the sum. Just like our arithmetic series, this is the sum of the n terms that we're adding together, and it looks like this is our formula. It has a fraction in it with an exponent and so on and so forth. So what are the terms that we use in our geometric series? Well, g sub 1 is the very first term in the geometric series that we're going to add together, and our ratio. And as we said earlier, you could find the ratio 2 ways. The first way we told you is you take any term and you divide it by the previous term, and that tells you what the ratio is. Or you can maybe spot it if you have a sigma notation. You may be able to spot it because it's the expression that's underneath your exponent. That's where you can find your ratio. The n represents how many terms you're adding together in your series. So if you're adding the terms together from 1 to 5, it may look like it is 5 terms in it. So when we get to the bottom, I think that would be 5 terms, but there's another thing I want to tell you. Like if you're trying to find the number of terms in your series and there's not a 1 that's down at the bottom of your sigma, this is what you do. The value of n can be found by taking the number on top of your sigma or your terminating value of your index. So I'm going to just put the words top number. Then you're going to subtract the bottom number minus your bottom number of the first index value. But this gives you a difference. You always have to do the following. You're always going to have to add 1 to it. So this will work if I use from 5 to 1. So if I take 5, I take away 1, that will only leave us 4, but I'm really adding together 5 terms. So it's top minus bottom, but you have to add 1 back. Don't forget to do that. And then this S sub n will, of course, represent the sum of all your terms. Let's see how this all works. I need 3 things. I need my g sub 1, my r, and my n. So let's take a look. Let's find our g sub 1, the value of my first term. The first term not in my sequence, so I don't automatically put a 1 here. It really matters what's at the bottom of your sigma. It's the first term in your series. So plug in the value of 1. 1 take away 1 is 0. Of course, any non-zero base to the 0 equals 1, and 1 times 3, or 3 times 1, gives you 3. The very first term in your series is 3. Now, we don't even need to find the value of the second term or even the last term to use this formula. We just need to know what our ratio is. And again, we could just take the any term and divide it by the previous term, but I don't see any terms. It looks to me like our ratio is going to be a 4 because we learned the explicit formula for a geometric sequence. And so I'm just going to call it 4. The last variable we need is the value of n. How many terms are we adding together? If we're adding the first to the 5th term, that is the 1st, 2nd, 3rd, 4th, 5th. Yes, that is 5 terms. Again, we told you take the top number minus the bottom number and add 1 back to it. That gives you our value for how many terms we're adding together. Let's start plugging in this formula. S sub 5, because we're adding 5 terms together. The sum of my 5 terms can be found by taking the value of my first term, multiplying it by 1 minus my ratio, which is 4, raised to the n. Because it's 5 terms, we're going to raise this to the 5th power. Then divide this all by 1 minus my ratio again down here. So you take the first term, multiply it by the expression 1 minus the ratio to the value of n, and divide it by 1 minus this ratio. Now there are parentheses written in down in the denominator, and I wrote them in here. There are parentheses surrounding your ratio, because if your ratio is negative, you want to power it correctly. There's another set of parentheses that are not written in that if you're using your calculator, you want to be sure to link together your entire numerator. So there needs to be a set of parentheses in the very top that represents your numerator, where it begins and where it ends. When I do this on my calculator, let's see if we can see the screen. This is what I get. I start with that parentheses in the numerator that's not written in there, but it's implied. So I'm going to start with a left parenthesis, 3, another left parenthesis, 1 minus, my ratio gets a parenthesis itself. Close that first right parenthesis around your ratio, raise it to the exponent 5, move down, right parenthesis to close out the expression inside, and then another right parenthesis to close out the numerator. Next, I'm going to divide by another set of parentheses, 1 minus my ratio, or 1 minus 4. Hitting enter, I should get the number 1023. So the value of the first 5 terms in the series is 1023. Now, I get it. It's only 5 terms. Maybe we could have just, grinded it out and just added together 3 plus 12 if I multiply by 4 to get my next term, plus 4 times 12 is 48, plus 192, plus the value of my last term, which I think was like something like 768 or something like that. Let's just do the math. So 4 times 2 is an 8. 4 times 9 is 36. Drop the 6, carry the 3. 4 times 100 is 400, plus 300 more is 768. Yeah, we could just add these all together using our calculator. What we should do is get the same sum. 3 plus 12 plus 48 plus 192 plus 768. And it works. Now it's supposed to work. We're supposed to get the same sum, but at least now you believe me that this formula is going to save you time for generating all these terms out and adding them together separately. Let's take a look at exercise 2 next. It says we're going to take the values from 1 to 6. And what we need is, again, the same 3 set of terms. I need the value of my first term, the ratio, and how many terms there are, top minus bottom plus 1 more. So 6 take away, I think I said plus, it's 6 take away 1 plus 1 more. So that's 5 plus 1 more. We're adding 6 terms together. Did you notice the ratio is still hidden in here? It's 0.25, or 1/4 if you wish. And the value of my first term, you might think that it's 16, but it's actually 4. How come? Plug in the value of 1 and evaluate. 16 times 1/4 to the first is 16 times 1/4, which makes 4. Next, let's use our partial sum formula. S sub 6 equals the value of my first term, which is 4, left parenthesis 1 minus my ratio. That ratio needs to be inside of parentheses, especially if it's negative. Raise this to the n. So I have all my parentheses in place in the top, divided by 1 minus my ratio, 0.25. Now, I don't necessarily need to put parentheses down there because I'm not powering it. It's just a subtraction. But some of you who love parentheses might want to do that anyway. All right, here goes. Let's take a look. Let's left parenthesis the top, 4 minus 1 minus 0.25, except I got to go back and put the parentheses around my ratio. Raised to the 6th power. That closes the inside, and this closes the numerator, divided by 1 minus 0.25. When I hit enter, now I might get a decimal, and it's important for me to tell you that you really should not round this decimal. This is an exact value for all 6 terms. If you rounded it, then you're not necessarily adding together the exact values of those 6 terms. If your homework, which it might tell you to round to the nearest whole number or to the nearest tenth, if your directions on homework says round, then you should round. Instead, what I'm going to do is what I showed you before, is use the fraction button in my calculator. And I'll read this because the screen is a little bit difficult to read on YouTube. It's 1,365 divided by 256. This is the exact value for the sum of the very first 6 terms in this geometric series. That concludes section 8, a geometric series formula for a partial sum. Continue along with your studies. Good luck. There is homework questions on Delta Math. I'm going to actually maybe move on to section 9 while we'll still have daylight today. So good luck to you. All the best. Continue on to section 9.